Mobile CUDA. Mobile CUDA, easy to say, hard to do. We've been wanting to bring CUDA to mobile devices for half a decade. The challenge has been CUDA equals performance, CUDA equals parallel processing, mobile equals extremely low power. Low power, mobile means energy efficiency. And finally, we've been able to make that possible. After years of endeavor, we've made that possible. The first test that gave me the indication that this was in fact a dream that's going to come true is the fact that the Kepler GPU now powers 10 out of the world's 10 most energy efficient supercomputers. 10 of the top 10 greenest supercomputers are powered by CUDA GPUs. If we can power supercomputers, which is severely energy constrained, requires millions and millions of cores with so much energy efficiency, we can surely find a way to bring it to mobile. And finally, we've done that with the Tegra K1. Now, the Tegra K1 is the world's first mobile superchip. I announced it at CES. But the big deal about Tegra K1 is that this is the first GPU in our company that made it possible for us to unify the architecture of CUDA, unify the architecture of Kepler across the entire spectrum of everything we do. This is really a supercomputer on a chip, on a mobile chip. It's not cliche. It just runs like a supercomputer. What runs on our nation's fastest supercomputer, the Oak Ridge Titan, will run on this chip, just obviously much, much more slowly. Now the question is, what are we going to do with those 192 fully programmable CUDA cores? What are we going to do with 326 gigaflops in mobile? Well, one of the most exciting applications is computer vision. Computer vision on CUDA. Well, you saw earlier how Brian was training, teaching, learning, having the computer learn how to recognize images. Once that learning process is done, which is extremely computationally intensive, it's about 100 times more computationally intensive than the final recognition of the object, that last part, we download the parameters, or the weighting, what they call weights of the synapses, the trained brain, down to the card. And with these processors, we can now do computer vision. There's several steps in it. First of all, our chip has to detect the interesting objects. There are lots of pixels on the screen. The first step is feature detection. Which of the corners are interesting? The second is to track that feature, just like we track features. To track that feature, feature tracking. Third, once you could track the features, you could recognize those objects, classification. And one of the most important steps is to reconstruct the 3D world. Using multiple images or video, using techniques like structure from motion, basically taking multiple images and using geometric projection, figure out from 2D images what the 3D world is. From 2D images, lots of 2D images, resolve, reconstruct the 3D world, understand the 3D scene. Well, the amount of computation necessary, these aren't normal flops, these are usable flops. It takes about 30 gigaflops at 30 hertz to detect features, interesting features, Harris corners and such. It takes about 180 gigaflops to recognize an object. It took exaflops to teach it, and it takes gigaflops to recognize it. One object is pedestrians, of course, another object is cars, but eventually we'd like to teach the car how to recognize every object. A tree, a trash can, a stroller, a house, a fire hydrant. Avoid those. Object recognition, and of course, 3D scene interpretation. Well, researchers have been doing these computer vision techniques now for some time. And they've been using PCs with CUDA GPUs for their development. And finally, I am so excited that we can finally allow them to take their work and put it into the devices that they intended. Walking robots, driving robots, flying robots, swimming robots, stationary robots, robots, cars of all kinds. We can finally let them run their program, those CUDA computer vision programs, directly in the devices that they hope to build. Ladies and gentlemen, I'd like to introduce you to a brand new development kit called the Jetson TK1. This is the world's tiniest little supercomputer. The development kit, the SDK, comes with Linux, all of the wonderful programming tools that we've been developing over the years for all the supercomputers and scientists who are developing CUDA applications. Programming tools, CUDA compilers, profilers, graphics tools. We also include something really, really cool called VisionWorks. All of this, $192. Well, we decided on $192 because there's an elegance to that number, as you can tell. And I'm just happy the marketing team is just more delighted by the symmetry and the harmony of numbers than making money. That's the company we are. There you go. Thanks, Paul. Really beautiful. It also comes with this new SDK called VisionWorks. Just for games, we have an SDK called GameWorks. This is VisionWorks. And so VisionWorks is stacked on top of CUDA. It comes with a whole bunch of primitives, whether it's recognizing corners, detecting edges, or it could be or interesting features, or it could be classifying objects. Okay, parameters are loaded into this VisionWorks primitive system, and all of a sudden it recognizes objects. On top of it, there are simple pipelines that we've created for you, so they basically sample code and helping you get started on what a structure for motion algorithm would look like, object detection and object tracking algorithms to look like, and on top of that, you could develop your own application. Now this is really, really exciting for us. We now finally have CUDA from supercomputers to PCs, workstations, all the way down to mobile devices. And now that we've got it here, now that we've got Tegra and Kepler integrated together, we're really going to kick it into turbocharge. The next generation Tegra is codenamed Erista. Erista is going to be, well, really fast. It's going to be based on the Maxwell GPU architecture, even more energy efficient, even more high performance. I'll tell you a lot more about it as we get a little bit closer. It's just right around the corner. Erista, from a long line of great, inspiring code names. Tegra K1 was originally called Logan, as you remembered. Tegra 4 was called Wayne. Tegra 3 was called Kal-El. Erista is going to continue a long tradition of superheroes. I can't wait to see Erista.